Hi everyone, and we are here to talk about a couple of things related to AWS and all technologies we think that would be good to know. And here we are, I, Dmitri Laptev, Solutions Architect, and Viktor Vedmich, Senior Developers Advocate. And the topic of our today's workshop is optimizing cost with AWS Graviton 2 based services. So, what does it mean and why are we even talking about this? Let's see. So, let's start from Graviton 2. What are we talking about when we talk AWS Graviton 2? And here we have at AWS deepest computer platform choice. That means that we have instances for these categories. Yeah, we have a general purpose, burstable. That means that the instance can be granted with extra performance for a small amount of time, and then it goes back to baseline, and then when load increases, it again bursts. And that's what we call burstable instance. We have instances for compute-intensive operations, and that means more CPU power with less amount of RAM. And on the other hand, we have memory-intensive instances. That means more memory. And we have instances with high I/O for storage, and we have dense storage instances when amount of storage is more important. And we have GPU compute instances with obviously GPUs, and we have instances for graphics intensive applications. And these are instance categories we have at AWS. Then we have additional capabilities we can use with each of these types of instances. Processor type. Manufacturer could be Intel, AMD, or AWS. AWS produces our own processors. And there is the choice to choose a fast processor up to 4 gigahertz. It's possible to add very high memory footprint and instant storage. You also can choose it. HDD, SSD, NVMe. And accelerated computing, we have GPUs from NVIDIA, from AMD. We have our own accelerators, and we have PGA computing support. And different options of networking up to 100 gigabits. And then bare metal instances, not a virtual machine, just a bare metal machine. And we have different sizes of instances from nano with one CPU, half of gig of RAM, up to 32x large, more than 100 CPUs, many gigs of RAMs, and so on. So these are capabilities. And we have options, other options. Yeah, you could add Amazon EBS, virtual storage drives you could attach to your instance using network. And we have elastic inference, shared GPU accelerator. You could attach it also to any of your instances. And that gives us more than 400 instance types for every workload and business need. And when you have some need, when you have some task, you start to think about, oh yeah, that's memory intensive. I need a lot of RAM. And on the other hand, okay, I also need networking. And then, okay, I also need a couple of attachable hard drives. I want to back them up also. I want to connect them. And yeah, that gives us this option to go. That's how you usually choose the instance type. And we have broadest choice of processors. Of course, we have Intel's Xeon scalable processors, and we have AMD EPYC processors, and then we have AWS Graviton processors, and that's the topic of our today's workshop. Actually, what these processes are and how you can use them to increase performance or to reduce costs or to do both, to increase performance and to reduce costs. So that's how it works. We have AWS Nitro system. We have hypervisor, network storage, and security. Yeah, AWS Nitro is a custom chip built by AWS, and we add this to motherboard, and we don't have any more software hypervisor. We don't have a software that controls distribution of resources among virtual machines. Yeah, instead of this, we have hardware chip, and it acts as a hypervisor. It controls network, it controls storage, it controls security within a server. And then on the server, we have some amount of virtual machines. And another AWS custom chip is AWS Inferentia, our famous chip for machine learning appliances. You can use this, you can guess it from its name, for inference. So, for example, you have a machine learning model, you want to deploy it somewhere, and you need hardware acceleration. Usually, you use a GPU, and instead of this, you could use AWS Inferentia accelerator, and it's optimized for many machine learning frameworks. It gives good results, and that's a cost-effective way to make inferences. And another AWS custom chip is AWS Graviton 2. This is an ARM processor. This is what you could name CPU. Not Intel, not AMD, but AWS. And yeah, it works as ARM, and many nowadays applications can work with ARM processor, and you could achieve very good performance for these modern applications. And yeah, first of all, we had first generation of Gravitons. We named them just Graviton, and currently we have Gravitons 2. And there was a first ARM-based processor available in major cloud. No one did it before. And it's built on 64-bit ARM diverse cores with AWS designed silicon, and there was 16 nanometers manufacturing technology. And they were available up to 16 vCPUs and 10 gigabits in chains network, and excuse me, 3.5 gigabits bandwidth. With Graviton 2, that's the next generation, performance is increased, and there are 4 compute cores and 4 times more compute cores and 5 times faster memory. And again, it's built with 64-bit ARM Nevers cores and AWS design silicon, and it's using more advanced technological process, 7 nanometers. And now it's possible to have up to 64 vCPUs, up to 25 gigs of networking, and up to 18 gigs of EBS bandwidth, which gives us more and more power for virtually every workload. And that's how it looks like. You can see it on the screen. It says Annapurna Labs. It's an Amazon company which designs these chips, and then these chips being applied at AWS. And so it's possible to use this processor for web, for gaming services, open sources database. They work well there. For example, Postgre, it works just fine on Gravitons. It can be used for high performance computing. You can run a cluster of them and again achieve good performance. It works very well for in-memory caches. Redis is a good example of this. You could also use the chips for media encoding. Popular media encoding frameworks, again, are available on this platform. And of course, analytics. Of course, you can run microservices, and like every custom software that can be compiled for ARM processor can be run there. And that's what we are talking about in this workshop, and that's what we are going to demonstrate you later. And components of AWS Graviton instances are, of course, Graviton 2 CPU itself. Then we have Nitro security chip integrated into motherboards and protects hardware resources and acts as a hypervisor. And we have a Nitro card, which is a connector to an Elastic Block Store, which also acts as Elastic Network Adapter and is being used for monitoring and security. And here, Nitro Hypervisor. And its responsibility is memory and CPU allocation. And that gives us bare metal-like performance. And Graviton tool, why we pay attention to this? In many cases, it gives best price performance within their instance families. Usually, Graviton-based instances are 10-15% cheaper than the like instances of same amount of resources, and usually they give 10-15% better performance. And these are instance types available today. And M6G, that's for general purpose workloads, and T4G, burstable, yeah, when you need sometime extra resources. C6G, compute optimized, more CPUs, more CPU power, less amount of RAM. R4, more RAM, maybe less CPU power. C6GN, extra networking capabilities, up to 100 gigs. And X2GD, memory optimized, very cheap, very cheap RAM. And they are available now. So let's try this. Excuse me. Something is wrong with the hardware. All right. I beg my pardon. Seems like trackpad on my laptop stopped to work. I
Maybe
guess.
I can jump in and start share, for example.
Yeah.
Okay.
Thank you.
Uh,
And I'll grab the mouse meanwhile.
yeah. So I believe just like we are going to start our workshop, and I think one of the main link currently, guys. Please, first of all, if you have any questions, please don't hesitate to ask us in the chat. I can read, for example, or Dima can read it, and just like we can stop and interrupt and explain what is going on, what is it, and so on. So one of the main link currently, what we are going to open and start to do it, it's related to our workshop, and this one link. I hope, Alexandra, you can open it. Yeah.
Excuse me, Mr.
Yep.
Dmitri, could you stop the screen sharing, please?
Actually, I fixed the problem with the cursor, so we can proceed as planned. Actually.
Dima already shared the link to our workshop.
Okay.
Yeah.
Okay. So this is our workshop, and the link that Viktor had already shared leads to this web page. And yeah, that's available for everyone anytime. You can use this link if you want to go through the steps later once we finished. And it has many sections. They apply to containers, database, big data. Yeah, if you have any further questions or considerations after that, you could go to this workshop. You can open any of these sections and you can repeat the steps on your own. And first of all, we need to prepare the environment we will be working in. And there are two options: on your own and at an AWS event. We are not using usual AWS event infrastructure today because it's not an AWS event. So we assume that you already have AWS accounts, and that means that on your own section is built for you. And it says, okay, if you still have not created AWS account, that goes you through this process. Yeah, how to create an AWS account. Here, like what's to fill to every box, and how to choose a password, some standard things you do when you created an AWS account. And most importantly, it instructs you how to create a user for your workshop. You need to add a user, and you're going to use this user to run workshop steps. So you create a user, you name it workshop, and you then say, okay, I want to give this user access to AWS Management Console, meaning to UI, to browser console. And then you set any password you want. And then when it asks you about permissions, you grant this user administrator access, just to make it easier. Of course, we don't recommend in production workloads to give any of your users administrator access. We recommend you to use the principle of least privilege and to grant only permissions that any entity actually requires. But for simplicity's sake and for workshop purposes, you could just, for the time being, give this administrator access to this user. And once you have this user created, you see the URL you can use to sign in, and you should be set. And of course, if you previously had a user with administrator permissions, you can just use this user and log in by this user. In other words, if you can log in into your AWS account with a user with administrator permissions, you can just do it. If you don't have such a user, please create one using this guidance. Then we set up a workspace. And I understand that any of you have an IDE you like, or you just prefer a terminal. Maybe you like IDEA, maybe you like Visual Studio, maybe you like VS Code. But for this workshop, for demonstration purposes, we are going to use Cloud9 IDE, and all the workshop steps are designed to be executed in this IDE, and you can use this. And of course, if you're already familiar with Cloud9 IDE, that's okay. So first step, we setting this up. We are going to create an environment in Cloud9. To do this, log into AWS console with the user you already created, or if you already had admin access to AWS console, okay, just log in. And once you are in, you can search for services. Cloud9 is here. Or if you don't see it there, you could just search it in this search box. You type Cloud9 here, and yeah, here it is. Okay, now we going to create environment. You can use this button here, create environment, or you can go to this left sidebar, select your environments. And again, I don't have any environment created yet, so I only see this page and only this button, create environment, and that's actually what we need. First of all, we need to fill the name, and Okay, let's name it Graviton2 IDE. Then we click Next. Then we choose Create a new EC2 instance for environment. And then the recommended instance type for this workshop is M5X large. So you choose other instance types and you just type, you search for this instance type in this search box. Okay, that's the one we need. Yeah, instance settings, create new, other instance type, M5X large. Platform, Amazon Linux is totally fine for us. And this is the question, for how long Cloud9 waits before it shuts your EC2 instance down, 30 minutes, okay. That's a pretty nice feature. You don't have this instance where the ID running. You don't have it running 24/7. Yeah, it shuts it down after 30 minutes of inactivity. Then you click next step. Okay, we can review our name and settings there. Name is Graviton2 IDE, EC2 environment type, X5 large instance type, platform Amazon Linux, and we have IAM role auto-generated. IAM role, that means what's allowed this instance to do. Yeah, when we have this Cloud9 ID open, it's running on this EC2 instance, and this IAM role defines what is allowed to do when you run some commands in your IDE and when you run some commands on this instance. And we are going to turn it as the next step. So now we press create environment. And we need to wait for a little bit while it's creating. And while we are waiting, we can take a look at the next steps. So our next step would be to set up permissions for our IDE and for our environment. So here we need to create a new role, and we are also going to grant administrator access to this role. So for this, we go to IAM. Yeah, we can just click on this link. We click on this link, and we have this create role wizard open. So yeah, we are going to create a new role to define permissions for our ID. And in order to do this, we click on this link. And here we choose EC2 because Cloud9 ID is running on EC2. It's a proper choice for us. We click next, permissions. And again, for these workshop purposes, we are going to give this role administrator access. That means that we are okay with this Cloud9 ID is able to do everything in our account. And then we click next. We don't set any text. And we review this. And we name it Cloud9 admin role. It already exists. It already exists because I already have this role created in my account. But you name it. You put this name here and you click create role. After that, after the role is created, you go here to services and you select EC2 here. And you see your virtual machines running, and that's the one we are interested in, the virtual machine that was created to run our Cloud9 ID. You select this, you go to security, And you see, yeah, no IAM role still assigned to this machine. And we want to assign to this machine the role we've just created. In order to do this, you click Actions, you go to Security, and you press Modify IAM role. So once again, we have created the role that allows our IDE to do everything we want. We want to assign this role to the virtual machine where our IDE is running. In order to do this, we go to Services, we go to EC2, we select the proper instance with Cloud9 running. We can determine it by the name. We select this, we go to Actions, Security, Modify IAM role. And here we need to choose the role. And this is the one we've just created. Its name is Cloud9 admin role. That's what we want. Okay, now we just click Save. And we can confirm that everything is right. We choose this instance. We go to Security, and we see IAM role, Cloud9 admin role. Okay, just fine. That's what we wanted. And the last step we need to do to set up the IDE. Okay, meanwhile it's created. If you have this tab closed for some reason, yeah, you just open Services, you go to Cloud9. This is the environment we've created, and you press Open IDE. All right, and the last step, we go to Settings, this little gear at the top right corner. You press this, you scroll it down, you select AWS Settings, and you need to uncheck this, AWS Manage Temporary Credentials. Yeah, we are going to say, okay, please just use this IAM role we assigned to virtual machine before. Don't use any other managed temporary credentials. We don't want it, we don't need it. We're just fine with the role assigned to the virtual machine. So we uncheck this. Yeah, once again, this gearbox, settings, AWS settings, uncheck AWS managed temporary credentials. Okay, then you can tune other settings you like. For example, you can choose another theme. You can choose dark or white or flat or whatever. And you could allocate windows in the manner you want. And what we actually need in this workshop, we need a terminal. And in order to open this, you press plus, you select new terminal. Okay, the environment is all set. Let's go to prerequisites section. And first of all, we want to clone the Git repository with everything we need for this workshop. And here's the hint. Here you see these lines, and you may want to copy and paste them, but this little small button here copies it to your clipboard. So I want to repeat these lines. I want to clone the repo, and I want to go to folder of this repo. I just press this, copy to clipboard button. I open the IDE, my terminal is opened, and I paste it here. Okay. The repo is cloned, and we are in the proper folder. The next step, we want to update AWS CLI. Again, copy this to clipboard and paste it there. And yeah, CLI is successfully updated. Then we want to install additional utilities. Again, copy it here, paste it there. All right, everything is updated. Then that's the optional, but still for some parts of this workshop, we probably are not going to cover these parts of the workshop today. So this step is optional. You don't need MySQL client installed for today. But if you are going to run the next steps of this workshop at home, you're gonna need this. So let's install it just in case. Again, we copy it from the workshop page and we paste it to the terminal. All right, that's successfully installed. Then we are going to install Kubernetes tools. Yeah, today we're going to cover Kubernetes cluster and we definitely gonna need Kubernetes tools. Okay, this is installed. And then we set up our account, we set up our variables, we set up everything we need to access other AWS paths. Yeah, we set account ID, AWS origin, we get the role, we set all the environment variables, and we create a SSH key. We're also going to need this today. You just press enter 3 times and the SSH key again generates a new key for you. And we upload this key we just generated. I have the error here because I have already this key pair with this name. And in order to clean this error, I need to go to EC2. And here I open key pairs and I delete this one. Okay. And I try once again. Okay, everything is successfully. You probably don't have, don't get this error because you probably don't have the key pair with this name. But I had it before, and so I needed to delete the previous one before to create the new one. And the last step, we prepare AWS CDK. What AWS CDK is? That means Cloud Development Kit. Yeah, that's the capability to describe cloud resources with the programming languages of your choice. You could use Python, C#, JavaScript, many languages, and you describe cloud resources as you would describe any other objects in your software. And that's what AWS CDK is built. And here, through this workshop, we are going to have a few resources described in this manner in Python. And that's why we need AWS CDK installed to support this. You will see a couple of examples of this later. But now we just installed this AWS Cloud Development Kit. We have some resources described in Python. We are going to deploy later these resources to AWS. Okay, now we install AWS CDK that supports that. It collects all other parts related to every service. You could see EFS here. You could see Kinesis here. You could see S3 there. So it collected all the packages. And we bootstrap it. That means that CDK now is going to create all the necessary resources within account so that we can create the infrastructure we want. And it downloads a Docker image. Now we are waiting while it's being downloaded. Okay, that was successful. That means that CDK created within the account all the resources we need to proceed with the next steps. Okay, so we have installed everything we need to continue. We have installed everything we need to perform actual steps of this workshop. So let's start from the first section, Graviton 2 and containers. Yeah, here we are going to explore how to run workloads, it says, using native multi-architecture support in EKS, ECR, and developer tools. What does it mean? Yeah, we said Graviton 2 processors, they are IRM processors, not x86, not x86 we used to. Yeah, usually Intel and AMD processors, they are x86. At laptops, desktops, processors usually are also x86. The exception is Apple MacBooks new, based on M1 chip. They are also ARM, just like Gravitons. But usually, yeah, we work with x86. And that means that when we build the software, that would be nice to build this for both architectures, for x86 and for ARM. Yeah, for example, you develop it on your usual developer laptop. It knows nothing about ARM. You have just usual Intel something processor here, and you probably need a Docker image built for this architecture. But you're going to run your production workload on Gravitons, and that's a good idea. Yeah, they're faster, they're cheaper, and so on. And that means that you need to build this image for two architectures at the same time. Yeah, you need to instruct Docker, dear Docker, please build this image one time for the usual x86 and another time for ARM. In this section of this workshop, we are going to talk about how we're going to do this. And here we have two services mentioned, two container services mentioned. Sorry, one container service mentioned, AWS EKS, Elastic Kubernetes Service, that allows you to run a Kubernetes cluster with AWS Managed Master Node. And AWS ECR, another container service, Elastic Container Registry. That's the service where you push your images. Yeah, you build something, you upload it to ECR, and then you can run it on EKS. Just as simple. And AWS developers tools, code build, code deploy, code pipeline. They are DevOps tools, CI/CD tools. You could use code build to build your software, and you could use code deploy to deploy your software. And code pipeline is to orchestrate all of the steps. Yeah, you could define your pipeline and code pipeline. You say, please pull sources from there. Please execute code build to build sources, and please use code deploy to deploy sources. And what usually happens, you make this pipeline, you say, okay, my Git repository is there, and I want, okay, pull it. I want to build this. I want to, once it built, I want to push the image to, I built, Docker image I built to ECR, and I want to use code deploy to deploy this image I pushed to ECR to EKS. That's what usually happens. And now we are going to look how to adjust such pipeline to support Gravitons, to support ARM architecture. So, first of all, we are going to create the pipeline itself. Usually in the real world, often you already have some pipeline. You already build your software. But now we have the clean account and we are going to create the sample pipeline. And here, we are going to create the pipeline to build multi-architecture container images. Yeah, we want to create Docker images for both x86 and for ARM64 architecture. And that's how we have native multi-architecture support. Yeah, and we want to choose to which option we want to deploy this image. Yeah, for example, that's how we build x86 container. Yeah, we say, okay, this is the ID, and this is our environment. Yeah, we're going to use Amazon Linux image, and we are going to push this to this repository in ECR. And that's how we build ARM container. Yeah, we say, okay, we want to use, this is the difference. Yeah, we build, in order to build an ARM-based image, we need to have ARM environment. And the difference is we say, okay, we want Amazon Linux to ARM image, not the regular one. And yeah, we still push them to ECR, and we still have this repository URL. And of course, we have different build specifications for x86 and for ARM. And once we have them built, we push them to ECR and we tag this with commit hash. And here, this is the pipeline. Yeah. Once again, AWS Code Pipeline is orchestration service for CI/CD processes. And we see steps of our pipeline we are going to create. And first step is to get sources from Git commit or code commit or any other Git repository. And then we have to build in parallel for x86 and for ARM. And then we add multi-architecture manifest, and then we push everything to ECR. So let's create this. I understand that maybe for now that's too much, too many new things and too much text and too few pictures. So let's just deploy such pipeline, and once it's deployed, we can review it in the UI, in the console, to once again see what happens. In order to do this, I execute this CDK deploy pipeline. And I'm saying yes. And what happens here? CloudFormation, infrastructure as a service. You know what? We use this at AWS in order to deploy infrastructure and to define them in text files. So this template, this change set is created by CDK, and it starts to create resources. And you can see it there. This is how it's configured. Yeah. There are yeah, that's actually what I'm going to create. While it's creating, yeah, we're just waiting. Oh, I see a couple of errors there. Oh yeah. Yeah, I already have this. I already had these resources created, and I need to clean them up before.
Dima, if you do not mind, maybe I can switch because I didn't have this one resources, and I can show on how it looks like on my screen.
Yeah, sure. We can switch here at this point.
Yeah, let me share my screen. Yeah, you should see that like it's going on. Let me move what's also here. So just like want to highlight it why we say yes here, because during when we are going to deploy anything through the CDK, in most cases we just like made some changes in our EAM role, for example, make some permission changes and so on. For that reason, just like CDK ask, you're going to make all of these changes. Are you allowed to do it or no? And for that reason, we say, yes, of course, we want to do it. So, and as Dima mentioned, just like all of this stuff is located in this folder. And for example, if we open, let me just like pipeline this one, it's guys, CDK, it's very similar like when we create something through the Terraform, for example. Yeah, but in this case, we use real program languages, not like declarative approach, for example, or DSL, like, for example, in Terraform or in CloudFormation, when we use only JSON and so on. In this case, we use Python, super classical Python. We have some objects, we can modify some parameters for that, and so on, so on. And what currently is really happened under the hood, I understand like maybe it's very difficult to see what's going on here, just like read all of this code. But in reality, we create pipeline to build our two images. Not like two, we will do three different images. The first one is like for IRM processor, the second one for x86 processor, and the third one, it will be like for both of them. Just like, for example, if you're going to deploy to both different type of processor, we will do it also here. And if we switch, for example, to real console, let me do it, for example, like duplicate and line. Oh, failed. I believe just like we are waiting for still this execution. Yeah. And as soon as it will be appeared here and we will be able to see it. Also, for example, for build projects, yeah, there is 3 project. And as you can see, it's like it created 1 minute ago. And as I said, it will create 4 different type of architecture. The first one for x86, the second one it's multi-stage, like multi-type of architecture, and the last one for IRM template, for IRM processors. Yeah, it's finished. So the next step will be related to create all of this stuff. So first of all, we have to change our folder to our workshop. Let's do it. The next one, we will need to create a clone of our repository, what we created in AWS. I mean, currently during the CDK deployment, we create also repository where we are going to store our code. Code which we will just like copy from one repository to another repository. And let's do it. We clone an empty repository. The next step, it will be, as I said, copy from our own folders to new folders and to make it like commit and push to our repository. Let's copy all of these files. Files which located in Graviton 2, CS Gravitons, and under all of this application. As usual, if we are going to make some build of Docker files, Docker image, we should have a Docker file, and Docker files is here. So we copy all of this stuff, and just like to trigger, use just like as usual, if we need to trigger our CI/CD platform, we have to make some commit, some changes. Yeah, just like to make some trigger to do it. So we are going to switch the folder, add all of our changes, make some commit, and push to our repository. Let's do it. We made a push. Let's switch to our, for example, source, our repositories. And currently, if we open, we will be able to see all of our changes appeared here. As I said, like our Docker file, which we are going to use as a build file, it's like what we are going to build and deploy to our Kubernetes cluster. And build it only on different type of a processor architecture. Just like as we did this one, it should trigger our build process. And for example, now if we switch to our build project, we should see, yeah, like it's in progress because we made some changes. And as usual, for example, in Jenkins, GitLab, CI, GitHub, anywhere in CI/CD platform, if you do so many changes, it will trigger to run some build process, and maybe in some cases also deploy process. In our case, it's only a build process. And as I said, it will build for different type of platforms, like for x86 and for ARM templates, and also for BOS type, like undependable of type of processors. So meanwhile, we are waiting. We can see also how it looks like in the code a little bit deeper. For example, as Dmitri already mentioned, we have different type of virtual machines we are going to deploy it. You know, like for example, if you're familiar with Jenkins, you run your additional nodes where you execute it. And for IRM, we use IRM platform. Of course, yeah, for x86, we use like classical Intel processor type of virtual machines to do it. And also, there is one, we also specify some different build specification for different type of platform. Let's check what's going on with our pipelines. Also, just like as usual, you can go to the history, you can open your build pipelines and see what's currently is going on. And for example, currently, yeah, we already succeeded and everything looks good. Also, as results, for example, if we currently will switch to ACR, our container registry, we will see container registry, of course, yeah, and some images which should be appear here. Yes, x86 faster because it triggered a little bit earlier, and I believe just like in a couple of seconds, maybe minutes, we will see for IRM and for multi type of architecture also images here. Let's what else we can see here? Just like guys, in this CDK pipeline, we create everything. Just like don't avoid the situation. Just like you have to go to console, make some changes, and click on different buttons and so on. So on this file, just like it can be your homework, you can review it in details. We create a code pipeline called build ACR. We define how to build different type of Docker images, like not like different type, but for different platform, for ARM or for x86 and so on. And all of that described in the code. So CI/CD pipelines also described in the code. So it's like amazing situation when you can describe everything and just like start your project from scratch in any environment, like I mean, in any AWS account in a couple of minutes, and you will see this absolutely the same results. So let's check, maybe we can see some other images. No, still in progress. Let's back to our build. Oh, yeah, we can see one more images like succeeded, build succeeded, and we have to wait for one more. Yeah, it's triggered after, you know, like simultaneously we run for both of them, like x86 and IRM. And when we finish both of these pipelines, we run additional one which create Docker image for both platform. And just like our next step, it will be deploy EKS cluster, where we deploy just like different type of nodes for IRM and for x86 platform. And this Docker image we will deploy to both of platform. And then we will show how it looks like, for example, what will happen if I'm going to deploy for one platform of processor on another nodes, and how Kubernetes cluster will react on that. Yes. And currently we are ready to run this command. What this command will do it for us? First of all, it will just like define what's our ECR URI and what's our Docker image tag. So let's just like copy and run this command in our terminal and see the output. So first of all, we defined our multi-image tag, and it's this one, and also what is our container URI. So currently, if I just like, for example, Docker pull and can download all of these images in our own machine, I can use this URI. And for the future, like when we run our EKS cluster, we need to define this variable, and we use SSM, where we put our parameter and define this parameter like the container URI. So our next step, it will be deploy Kubernetes cluster. It's EKS. Absolutely the same what you can do it on your own. For example, run, I don't know, like through the kind, or I don't know, some other stuff, or use your own, or just like open source Kubernetes cluster. And again, we are going to use CDK. CDK will define for us all of these parameters, what's the version of Kubernetes cluster, how many nodes we are going to create, and so on. And the main point here is like we are going to create two node types. The first one is like for classical processor, and the second one IRM processor. Let's do it because it will take some time, and I think we will make some coffee break here. So we switch to our Graviton workshop and run deploy EKS cluster. And again, it asks us, I'm going to make some changes in YAM. Just like, please allow to do it. Yes, of course, allow. And start under the hood. The main idea, CDK will generate CloudFormation template, and use a classical way, apply this CloudFormation template in our AWS account. Just like to prove my words, let me show, for example, switch to CloudFormation. This one. And in our stack, we can see Graviton EKS create in progress. And I believe it will take up to 10 or 15 minutes because it's not so fast. We have to create a couple of virtual machines. We have to create a Kubernetes cluster, managed cluster, EKS, and so on. Meanwhile, we can just like open and see in details how it looks like. It looks like in the code. EKS, this one. We create security group, we create a cluster, define the version of this cluster, it's a public, what's a private, some default capacity, what's the VPC we are going to use, what's the security group, which we create a little bit earlier, what's the node type you're going to add, how many of the capacity will be here, scalable node group or not scalable. And by default, we create this two node instance. And in our next step, we will deploy pods per node, use pod affinity, anti-affinity. The first one is for x86, and as Dmitri on the start of our workshop mentioned, for different type of processor, we use different type of EC2 instance. And for example, for classical, as you can see, we use M5 large. For IRM processor, we use M6G large. So I don't know, like currently it will take up to 10, 15 minutes.
Yeah, I would say more likely, 10, 15. And I think that's the point, to have a short coffee break and to get back, let's say, in 10 minutes.
And just like, guys, if you have any questions, please type in the chat. We can just like come back to the previous step and try to explain one more time, or just like to be clear and understand what we are doing step by step. I understand sometimes it's very difficult to just like if you repeat, like it will be like monkey reproduce everything. Yeah, but our goal is try to explain what has happened under the hood and just like avoid the situation, just like some magic happened. It should be clear for you what's currently happened, what will be the next step, what we did already, and so on. So I think we will back in after it will finish. And meanwhile, if you have any questions, please.
So we are still waiting, and to take maybe 5-10 minutes more. EKS cluster initialization is not a very quick thing. While we are waiting, we could talk a little bit more about Graviton instances. And I'm going to get one more time the presenter role. And so while we are doing this, why are we creating a EKS cluster and doing these pipelines? Yeah, we want to demonstrate that you can run EKS cluster based on ARM chips, and you can build your software to support ARM chips. And it's not that hard, and in return you get better performance and lower costs. And that's why this workshop topic says cost optimization. Yeah, you run your service, you run your product, you switch it to Graviton, you get better performance, you get lower costs, like between. Other thing you can do in order to get this cost optimization is not only rebuilding your software for Gravitons. You could use a few products that support ARM Gravitons out of the box. And on this slide, you can see, these operating systems. They work just fine, being run on ARM, Amazon Linux, Ubuntu, Red Hat, SUSE, desktop. And yeah, that's what are we demonstrating right now and what we are building right now. Yeah, how to run Docker container with ARM64 on ECS or EKS. And the interesting part is here, these services that could help you. Yeah, that's what we are doing. We store sources in code commit. We build them using code pipeline, and yeah, we're doing this in Cloud9. And Systems Manager and CloudWatch, of course, they support Graviton-based instances, and you work with them just as you previously did. And here, ELSA databases. Yeah, you see them on the screen, and they also support ARM, and they also work fine on Gravitons. And it includes Cassandra, MariaDB, MySQL, Postgres, Redis, SQLDB. And that means that if you run a database on an EC2 instance or in RDS, AWS Relational Database Service, you could get cost optimization by switching to Graviton-based instances, just like that. You don't need to recompile something. You don't need to support another architecture. You go to RDS, you launch a new DB cluster. You say, I want this cluster being run on Gravitons. Okay, you get Graviton-based instances with bit lower prices, with better performance. And this configuration and monitoring tools also support ARM. Of course, Chief, Honeycomb, New Relic. You can use Terraform on your Graviton-based instances, obviously. And you can use these security tools. They also support Gravitons. So very wide range of services, very like for many of them, that's easy to start on Graviton. Yeah, for example, for MySQL, okay, you just download IRM compiled MySQL for Gravitons, and it just works. Same for Redis. And these CI/CD tools, they also support IRM. Yeah, if you want to use GitHub Actions, GitLab, Jenkins, also supported, also available. And some of performance, KDB, yeah, it could be even 2 times cheaper. Hourly cost relative to performance, you can see this graph here, M6G, yeah, on large instances is this, x large this, 2x large this, yeah, and it always, there is always a advantage. It's always lower cost relative to performance for KDB. Honeycomb, they started to use Gravitons and they achieved 30% fewer instances. Yeah, previously they needed to use, let's pick some arbitrary number. Yeah, if previously they needed to use 100 EC2 instances to run their services, they switched to Gravitons and now they need only 70 instances to run their services with the more or less same performance. And some customer feedbacks. Yeah, Snap, Nextroll, SmugMug, they switched to Gravitons. They used Erlang, Go, Java. They used EKS. They did the switch. We are doing this workshop, and yeah, that was fine. Lower cost, better performance, works okay. Few more benchmarks. Spec CPU 2017. Just synthetic benchmark being run on M5 and TIP6G. Yeah, as I said, a little bit better. Load balancing with Nginx. Nginx also supports IRM. You can also run Nginx on Gravitons, and 24% better performance for load balancing. Memcached, another example, supports Graviton, supports IRM. 43% better throughput. Video encoding, X264, 26% better in terms of frames per second being encoded. Machine learning, yeah, this model, BERT, text encoder, widely being used for natural language processing. Graviton 2 has FP16 and 8 support to accelerate machine learning workloads, 28% better performance. Amazon RDS, that's what I mentioned previously, relational database service. You can run it on Graviton processors, just as simple. Yeah, you create a cluster, you select I want them being run on R6G instead of R5, and you get this result. When the number of connections is relatively low, yeah, performance is more or less the same because instances obviously are underloaded with this number of connections. When load increases, Graviton starts to demonstrate better results. You see here, L6G 16x large, R5 16x large. Instances of the same amount of resources, difference is only with CPU type. And yeah, when number of connection increases, it has 1.5 better performance.
And let's back to demonstration. It's currently finished. So
Okay.
I will, yeah. So currently what we can see, our EKS cluster have been deployed and did 4 instances. As I mentioned previously, one of them for classical processor and some of them for new IRM processors. And let's back to our workshop. So first of all, we have to connect to our Kubernetes cluster, and this command will help us to do it. So through the cloud formation, we will describe our stack and get the command how to connect, authenticate in our Kubernetes cluster. Let's do it. So, and currently, if we just like type kubectl, I don't know, get nodes, for example, we should see our nodes. Yes, here. Absolutely the same. We can just like copy this command from our workshop, and it will additional show us labels. The shell labels show us what the architecture is. It's AMD 64 or it's IRM. It's like classical or new version of type of processors. And we are ready to deploy. We are ready to deploy our Docker image. Before that, we have to, I mean, like not the Docker image deploy. We are going to deploy, Docker image with deployment. So this command will help us to do it. So first of all, we define our container URI and make some changes in our deployment YAML. Let's do it, and I will switch to the code and show a little bit in detail what's going on. Meanwhile, we are waiting for. So let's open this Graviton 2 CS Graviton deployment YAML. It will be here. So we are going to create namespace. Also, we will create service with type of load balancer, and in our AWS console, we will see load balancer. And also we have a deployment. And this deployment, we have four replicas. And the most interesting, I believe it's here. We have affinity and pod anti-affinity. In affinity, we say we just like happy currently to deploy on both of type of instances. I mean, like in classical processor or with new processor. For us, it doesn't matter because we define here two values: AMD 64 or IRM 64. AMD 64 is like classical x86. What affinity will help us to do it is like deploy per node one container, one pod. So and also in containers, here we define our container URI. If you remember previously, I said like in our ACR, we upload for x64 and for 86 for both type of processors, and multiple, which we can deploy on anyone. And currently, if we, for example, back to our terminal and just like type the command to see what's going on with our deployment and our services, we will see that like services up and running, load balancer, and all of our pods also up and running. Let me just like double check. kubectl get pods minus n t arch, and it's like namespace. I'm going to get all of pods from namespace multi-arch. 4 pods up and running. Also, if we switch to our console and open AC2 and open load balancers, we can see one of load balancer. Just like, yes, one of the load balancer active. And for example, if we get this value and try to, like send a request to this load balancer through the terminal, for example, we will see different answer of a different type of architecture, like from one of them is x64, IRM, just like depends where we just like send this request. And if you repeat the same iteration, we will see just like different responses. Yeah, the first three from was classical, other from IRM. So it's currently what we achieved. We deploy our container to both node groups for classical processor and for new processors. Our next step is like deploy absolutely just like to show what will happen in case if I define some specific version of container. I mean, which I build for specific version of architecture. First of all, we are going to say just like a count of replica, count of pods which we currently have in our deployment, cut down to 0. Let's do it. And now if I try to see what's going on with the pods, I should see that all of them should be in the terminated state. Yes, it's going to, deployment is going to kill all of these pods. The next step is I'm going to change the version of container URI in our deployment, make changes through the deployment. I use the Kubernetes approach through the kubectl and so on, set the image. The deployment has been upgraded, updated, and let's back to our count of replicas. In this case, just like what's we done, we change our URI for our images, for our container, and back to the count of replicas. And the expected result should be, like 2 containers, 2 pods should be up and running. 2 of them should be in some crash loop back state. Let's double check. kubectl get pod minus n. And as I said, like 2 of them running, 2 of them is crash loop back. Let's additional byte to see what's going on. It's where it's right located, and some of them it's one architecture, some of them is other architecture, and of course, as expected, some container will be in the error state. And the next step, it will be related to build and deploy ASP.NET Core application. But honestly, I'm not sure like we have enough time. Maybe let's try and see how much we can do it, use our time. So first of all, we have to switch to our Grayton workshop and again, make some deployments through the CDK. The CDK will deploy additional code pipeline. Create additional pipeline. Through this pipeline, we will build and deploy ASP.NET application. In this case, again, it will be, of course, a Docker image. But anyway, it will require to create separate pipelines. Let's start it. Let's reach to our process. Also, we need to create a clone of Docker.NET Docker Git, where we are going to use some of the Docker images, Docker container file. The next step is like create or clone again from the scratch repository, which will be created by this CDK. I believe it should be a little bit faster than previously. Also, as usual, you can read and review all of the steps in this file. It's created through the Python. So what we have here, create container repository, new one, create a additional repository where we are going to store our code, create a pipeline, as I mentioned, and configure this pipeline. Create a Docker build process for IRM, and it will specifically created for ASP.NET. Also, we define some source action, what will happen if we make some changes, and some stage for our pipeline. Let's back to this one. It still is creating. Yeah, container registry are already created for our ASP.NET. There is no images as expected. Let's switch to pipelines. In our pipelines still have not created, waiting for a little bit. As usual, if you're working with CDK, it's create additional cloud formation. In general, like, it doesn't matter which language you're going to use to write your CDK template, it will generate JSON for cloud formation. And the main idea is to like send your cloud formation to cloud formation template to cloud formation in AWS. And like, for example, currently, as we can see, Graviton ID pipeline.net is in the progress. We can see all of the events as usual as previously when we use CloudFormation, when we create our JSON files and deploy it. But as you can see, it will take not so much code if we compare with JSON. And just like if you're familiar with Python or TypeScript or some other languages, just like you can pretty easy to use it, and it will be much more faster to create your infrastructure use a code. So we create the QMS alias, YAM policy, event rules. Three steps left. Yeah, let's check this, like our cloud formation stacks completed. Yes, completed. And we're ready to move to the next step. First of all, we have to clone Git repository. As you can see, we clone is like in the first tips. We don't need to clone all of code from this repository. In general, we need to see only Docker file. The next step is clone our empty repository, which we created by CDK. Let's do it. It should be very fast. Yeah, it's great. As you can see, separate folders, clones here. It's absolutely empty. The next step is copy from this repository to our own repository in AWS. Let's do it. So yeah, and you can see the recipe at all of these files. As I mentioned, for us, the most important is this one, Docker files. The next step is make commit to our repository. Let's do it. So it's a copy of the add to our Git and push to our repositories. And it should trigger our code pipeline. Let's go to our pipeline. And as usual, like if you're working with CI/CD, it should trigger by any events in your source code, like in Git. We made some changes and it trigger our pipeline. So we can see what's included in this pipeline. The main idea is build our Docker image and upload to our ACR. And after that, we will be able to deploy this container to our Kubernetes cluster on our Graviton node group instances. So we can open our build project and see what's going on with our pipeline. It will take some time as previously. Look like previous builds was a little bit faster. Not the first one. The first one took around almost 4 minutes. I believe it will also take around 4 minutes. as you see, current phase pre-built. Previous phase was related to provisioning. Just like we try to save your money, don't like up and running some machines for building process, and only when you make some changes, up and running some machine and run your build process. So currently Docker started to build this one, pulling some layers. So succeeded, that's great. So currently we should see in our containers a new image. Registry, yeah, span.net, it's image here, it's great. We're ready to back to our workshop. This command, as usual, we define our wrapper array, image tag, and our container array, and put it in our SSM. So let's do it. Yeah. And I think almost the last step for today, we are going to deploy our ASP.NET application. Let's just like review it, how it looks like. Again, we are going to create a new namespace in our Kubernetes cluster, create separate service. As previously, it's a load balancer, and deployment. In this case, we are going to use only 2 replicas. We don't need it more. And in affinity section, we define not affinity, where we say, please deploy only on IRM 64 processors, just like use labels, of course. And the port anti-affinity, which help us to achieve the situation when only one port will appear per node. So again, it will take some time. Currently, we can just like open, for example, EC2 and open our load balancers. Yeah, one of them is like in the provision state. If we back to our console terminal and try to get from our new namespace, it's ASP.NET. Should see to up, but load balancer currently is provisioning states. This command will help us to see our services deployment and port in our new namespace. It's like absolutely the same as I previously showed. So services load balancer, what the cluster IP, what the external IP will be, and what's the name of deployment, how many pods do we have up and running, and so on. Just like for us currently, it's most important, it's waiting for when our state of load balancer will be active, not provisioning. But just like we can try to open this one. Please prepare. Yeah, as expected, still provisioning. Meanwhile, we are waiting. I want to summarize our workshop. Just like guys, if you want to save some money, as usual, AWS can help you to do it. Graviton instances can achieve up to 40% performance, and just like use them for your own application. As Dmitri mentioned, you can use, for example, for your Nginx instance, Memcache, databases, and all other your stuff applications. And you can achieve up to 40% performance increase in this case. Yeah, active state. And let's see one more time what's address. It should be the same, but anyway, let's just like copy. Yeah. Our .NET application deployed in our Graviton image instances, and we see this application working up and running, and great. Pass to you, maybe to summarize.
Yeah, sure. I just like to say the same as Victor has already said. Graviton 2 is the good way to have like easy win. What we've done is not that complicated and still gives you a performance benefit and cost benefit. So it definitely worth attention, in my opinion. And yeah, that's a good way to keep in mind while you are planning starting of new workloads, new databases, and so on. So thank you, everyone have been who's been with us today, and thank you for watching this. And of course, you can repeat the steps or perform additional sections of this workshop later using the same link we gave at the beginning. It will be active all the time. So thank you again.
And the super last word from my side, guys, just like again, try to save your money. Please don't forget to do this step, like clean all of your environment, what we today already done. It will delete absolutely everything, like Kubernetes cluster, repository, everything, which will cost any money in your AWS account. Please don't forget to do it. And again, thank you very much. See you in the internet.